get into how to simplify square roots. And there's two different ways to do it. I do not care how you do it. I put both methods on here. I'm going to show you both. We're going to practice both. We're going to do 3 of each. So one, this is kind of how I do it when we've been working on these. I like to use perfect squares. So like the biggest perfect square that goes into 48 was 16. You've seen me use this method before. I'm also going to make the little list of perfect squares for us so it's in front of you. Like 1 square, 2 square, 3 square, 4 square. I can do this all day. 5 square, 6 square, 7 square, 8 square. Okay, we're probably getting carried away. But again, you can make that list forever. So you're looking for that biggest perfect square that goes into the number. That's usually how I do it, and that's the first 3 I'm going to do. Now, the other way, which I think they also show you in Algebra 1, it's been a hot minute since I've taught Algebra 1, is they use these prime factors. Or maybe you're used to seeing it more in a tree style. Does that look at all familiar? Like 48, you could do like 4 times 12. Those clearly are not prime. Prime's only divisible by 1 in itself, so I'm going to keep going. 4, I could do 2 and 2. 12, I could do 4 and 3. Now, 4 is not prime yet. You can still break that down. So that's what they've got, all of your prime factors here. I don't care which way you do these, okay? I'm going to show you both. We're going to practice both. So if you're doing the prime factors, because this looks kind of crazy, all of the stuff they have written here. So you're working on a square root, square, 2. You're looking for groups of 2. So there's one of them. So there's that 2. Here's another pair of 2s. So another 2 goes out front. And then remember your poor little single numbers, like you only have 1, 3, that guy stays underneath. So we're going to practice both methods. You pick your poison on how you want to simplify them. It doesn't matter to me. I'll never force you to do one method or another, as long as you can simplify. So I'm going to start with the perfect square. So I'm going to flip back here. We're going to look at these green numbers. 72. You might need your calculator for this. These are, some of these get a little big. What's the biggest perfect square that goes into 72? Off your list. You might have to do a little guess and check and try it. I hear calculator keys clicking. 9 does. Is there a bigger one? There's a bigger one. Anybody got it? All right. This,
36.
ooh, Tusky with the win. 36 goes into 72. How many times does 36 go into 72? Okay. So I'm going to click it here. I'm going to rewrite 72 as 36 times 2. And now, simple. The square root of 36 comes out nice. What is the square root of 36? 6. So my final answer is 6 square roots of 2. So we have simplified them like this in the past. This is usually kind of how I like to do it, but you can pick your poison. So 48. Now, that was already above on your page. I just wanted to go through and explain it to you, because I think some of that's a little confusing looking. So 48, the biggest perfect square that goes into 48 was 16. Super easy. What's the square root of 16? 4. So 4 square roots of 3. Okay, I'm going to click it back to our list of numbers because 90. So off the green list, what's the biggest perfect square that goes into 90? 9. 9 times what? 10. So I'm going to rewrite this 9 times 10. Now, we've seen where we have that coefficient, talking about the 5, the coefficient in front. Remember, you're really multiplying all of this stuff together. What's the square root of 9? 3. So we're going to have 3 square roots of 10 for that part. Don't forget you still have the 5. So what's your best perfect final answer? Got it. So this is kind of how I lean towards doing them, is with the perfect squares. Again, it doesn't matter. We're going to do the next round with the factor trees. So I'm going to do it the purple style over there. I'm going to show you that style too. On your homework, it just says simplify. You do whatever makes the most sense to you. So I'm going to start with 32. So I'm thinking about, okay, 2 numbers that multiply to 32. You got choices. You can do 2 and 16. You can do 4 times 8, whatever. I'm going to do 4 times 8. Now we're 4 and 8 prime numbers. No, you could still break those down further. So 4, of course, 2 times 2. 8, I'm going to go 2 times 4. And I can still break those down further. The 4 can be broken down into 2 times 2. So every number at the end of your branches on a factor tree, the numbers at the end, should be prime, divisible by 1 in themselves. Now, what you're looking for, square root. You're looking for groups of 2. I'm looking for a pair. So here's a pair of 2's. Here's a pair of 2's also. And don't forget you have this single. So to get your final answer, so whatever number you have a pair of, so this group in the green, I have a pair of 2's, so I'm going to have a 2 out front. I had another pair of 2's, so I'm going to have another 2 out front. And then the single number stays underneath. And then I'm just going to simplify that and put my final answer as 4 square roots of 2. Now again, I don't care which way you do it. Personally, for me, it's faster to do it with the perfect squares because I know that list of perfect squares. Because I'm like, oh, I could have done 16 times 2, square root of 16, 4, had it, okay? I'm just showing you both ways, whatever you like. Okay, 135 ends in 5. So the first thing I would check, how many times does 5 go into 135? How many times? 27. Now, I can still break these numbers down. 5, of course, is prime. I'm going to leave that. The 27, I'm going to go 9 and 3. 9, I can still break down 3 times 3. Okay, so we are looking for a pair of numbers for our square root. So you do have a pair of 3's. It doesn't matter which pair you circle, just circle a pair. And then, of course, you have a single 5 and a single 3. Now, to get your final answer, whatever number you had a pair of, 3, goes out front. Underneath the square root then are your single numbers. So we had a single 5, and remember we multiply all of this stuff together, it's still a product between everything, and then a single 3. So I'm going to put my final answer is 3 square roots of 15. So again, however you want to do these today on your homework, you get to pick. One more, I just wasn't sure I could fit it all in the same slide. Okay, 240. Let's simplify that. So first things first, just, a little number theory, a little number sense. I see it ends in 0, so I know 10 goes into it instantly. 10 goes into it how many times? 24. And again, there's lots of different combinations to get 240. You can pick whatever you want. I just, the 0 popped out to me, so I went 10 and 24. Now, 10, I can go 5 and 2. Those are both prime, so I'm looking pretty good there. What do you want to use for 24? You got some choices, doesn't matter, pick. 6 and 4, Cass says, I'm with you. Now, both of those we can break down more. 6, I'm going to go 2 times 3. Those are both prime, looking good. 2 and 2. So now again, I'm looking for a pair of numbers. So here's a pair of 2's. Here's another pair of 2's. And then I've got my single numbers. So we have to put all of this together for our final answer. A lot of numbers up here. Now, don't forget you have this 2 in the front. I'm just going to leave him in there for right now, and I'm going to get into the factor tree. So again, what did I have a pair of? Well, the 2's. And then I'm going to do the singles. So, let me erase here. I need longer arms. And then we had another pair of 2's, so I'm going to put a blue 2 out here. I am going to multiply all of that together in a minute. Let's do our square root. And then our single numbers. You had a single 5, a single 3. Now that looks like a hot mess, but we can simplify that super easy. Do the front first. What's 2 times 2 times 2? 8. So I have 8 square roots of 15. So do I think one way is better than another? No, I sure don't. It's just really what you prefer to do. So on your homework, you can either do the factor tree style. I left you enough room for that. Or you can do it with the perfect squares. It's completely your call. It doesn't matter to me. Just for the record. Now, the last thing we're going to show you. This is something I know you covered in Algebra 1, but again, it's been a while. This comes up a lot this chapter. We're going to have a lot of square roots in our answers this chapter. You can never, it's one of those kind of unwritten algebra rules, never have a radical, a square root, in the bottom of a fraction. So we're going to quote unquote rationalize the denominator is the very fancy name. So when I see the square root of 2, you have to put another square root of 2 on. And whatever you put on the bottom, you put on the top. Now the reason is, on the bottom, that turns out nice. You're going to have the square root of 4 which is just a very nice number. So it gets rid of the radical in the denominator. If you in your calculator type 5 divided by the square root of 2 in, it's going to give you some gross decimal, of course. If you type this last final answer in, it gives you that exact same gross decimal. These are the same values, they're just different styles. 2 4s, 4 8s, 3 6, they're all a half, they just look different. So we're going to just practice again, review how to rationalize the denominator. So again, you can't have a square root of 5 on here, so I'm going to put another one on. Whatever you put on the bottom, you got to balance and put on the top. All right, easy peasy. Now, you cannot multiply the 3 and the 5 on the top together because one's in a radical, one is not. So I'm really just writing it down. Now, because both the 5s in the bottom are underneath radicals, you can multiply those together. 5 and 5, 25. Now, some of you might even skip this step because you can mental math it. Because you know the square root of 25 is just going to turn out to be what? 5. So some of you might skip that step and just go straight to this. Now, final question I'm going to ask you, because sometimes I'll see kids that will say, hey, I'm going to reduce 5 and 5 and make this a 1. Can you do that? No, one's under a square root, one is not. We're just going to leave it. So some of you might have been able to do that in one step and skip the middle. I don't care, whatever. Okay. Same thing for this one. You can't have the square root of 2, so I'm going to put another one on. And then, of course, I'm going to balance the top. Put the same thing on the top. Now, same spiel as the last one. 6 and 2, one's not in a root, one is. You can't multiply them together. Just write it down. Now, some of you, let's see if we're good. Can we go right to the final answer on the bottom? Because you would have the square root of 4. What's the square root of 4? 2. So some of you might just put 2 right now. Of course, you know I can't help myself. I'm going to put all this stuff. Now, before I circle that, there is a little simplifying you could still do. What could you reduce? 6 and 2. Because what's 6 over 2 really? 3. So final answer, 3 square roots of 2. And again, you might do this in less work than what I'm doing it. I don't care. It's totally fine. So we're going to see this a lot. So we're going to practice it a little bit here today. Now, I don't care about the square root on 5 on the top. You can have a square root on the bottom. That's fine. It's the 3 that's the problem. So same thing. I'm going to rationalize the denominator with the square root of 3. Top can be whatever. It's just the bottom. So the top, kind of nice. They're both under square roots. So I'm going to multiply 5 and 3 together. Some of you can go right to the bottom because you're going to have the square root of 9. What's the square root of 9? 3. Let's just put a 3 in, make our lives easy. Last question. Can I simplify the 15 and the 3? Nope, one's under root, one's not. We're done. Circle it. Easy peasy. All right, D. I know, we're doing a lot of these. Now on D, because they all have a little twist to them. On D, notice I got fancy and put a 3 on the bottom here with it. Guess what? I don't care about the 3. The 3 is not a problem. It's the square root of 7. So you still are just multiplying by whatever the square root number is. Could you put a 3? 3 square roots of 7? Sure, but it's just more simplifying at the end. Why do extra work? We don't want to do extra work. We're tired. Okay, top, 2 square roots of 7. That's easy. The bottom, don't forget you have the 3. Let's put him in. Now again, a lot of you are probably going to skip this step. I don't care. Square root of 7, square root of 7, square root of 49. What's the square root of 49? 7. And I'm going to do times 3. So what do you have on the bottom really? 21. Is there any simplifying you can do before you circle that? No. Under a root with the 7, so I can't with the 21. 2 and 21 don't reduce. We're done. All right. You're like, gosh, why are we doing one more? Well, I got to show you kind of a trick on this one. So I look at this, and right away I'm like, oh, let's do the square root of 6. You can do that. You can do it. You're going to simplify, but yeah, that's going to take a little bit more work. So I'm going to show you, for those of you that are just like in the groove, you can just do your square root of 6. I'm going to show you a shortcut too here in a minute. So on the top, so I'm going to have 3 square roots of, you tell me, 3 square roots of 12, which I can simplify that. So I'm already kind of groaning about it. I've got the 5, square root of 6, square root of 6. And I know you can simplify, and some of you might have skipped what I just wrote, which is fine. To the top, you got your 3 square roots of 12. What do you have on the bottom? 6 times 5, which is 30. What can you simplify? We can simplify the square root of 12. What else can be simplified? The 3 and the 30. Does it matter which I do first? No, because it all has to get done, right? Now, I heard square root of 12 first, so I'm going to do square root of 12 first. You know I like to use the perfect squares. 12 is small. I know the biggest perfect square that goes into that is 4. So I'm thinking about it as 4 times 3. I'm going to move up here to the top so I'm not at the bottom. So I'm thinking about that as 4 times 3. This is the never-ending problem, people. Ooh. What's the square root of 4? 2. Times 3 in the front. 6. So we have 6 square roots of 3, 30 on the bottom. And we're almost done. What are you going to reduce now? 6 and 30. Oh, that was a lot for a first day back after winter break, if you ask me. Now, there is a shortcut to this one. This is the only one you have a shortcut to, and I'll show you why in a minute. So I could have done this in a lot less steps. Here's why. I saw this right away. Those are both under roots. Could you simplify them? Since they're both under radicals. Does 2 over 6 reduce? What's 2 over 6 really? 1 over 3, right? So I have the 3 in front. I could have made this a 1. I could have made this a 3. Now, what's the square root of 1? 1. What's 1 times 3 on the top? 3. Who cares about the square root of 1, right? Is really what I'm getting at. So I'm like, ooh, short and sweet. I'm going to rationalize. I'm going to put a root 3 on. So I'm going to have 3 square roots of 3 on the top. Square root of 3, square root of 3, square root of 9. And you can see we're going to get the same answer. We're almost done. What's square root of 9? Times 5. And when you reduce your 3 over 15, we have the same answer, and I did it in a whole lot less steps. But you have to catch, you could reduce the 2 over 6. Notice, none of the others that works. 5 over 3 didn't simplify. So that's why I didn't try to do any sort of fancy shortcut. You don't have 2 roots to simplify on that. So I just wanted to show you, if you see that, if you reduce first, it will make less work for you in the end, okay? So like I said, you've got front and back worksheet for homework.